Okay, in this video we're going to take a look at skeletal animation among other things. But so far in the class this semester we've looked at some various ways to animate 3D models, and generally we can break those down into two types. One is rigid body animation and the other is non-rigid body animation. In rigid body animation, basically the two ways that we've looked at animating models are simply moving them around in your program using a transformation matrix. And also we looked at hierarchical models, which gives you the ability to transform the different parts to a model. But using those two techniques, generally the shape of the model itself doesn't change, only the relative position of the model and the parts of the model. And so that's why we refer to that as rigid body animation. With non-rigid body animation, what we can do is take a model and not just move it around in our program, but we can also change the shape of it. And so the first way that we looked at doing that was using morphing, where you create in your Lightwave model a set of morph targets, and then in the program you manipulate those. The next way we're going to look at performing non-rigid body animation is using skeletal animation. And so in skeletal animation we'll have an internal skeleton that we'll use to control the model. So for this video I'm going to look at demo 12, and demo 12 has an example of a model that uses skeletal animation. So let's take a look at this model. First of all, in this program, two models are being drawn. There's a floor using multi-texturing, which is a technique that we've seen before. And also, we've got a secondary model, which I've called a flower. And it's really not a flower, although that was the, it might look like a flower more than anything else. But this model is just an attempt to showcase the capability for skeletal animation, to basically just show how it works. Now, obviously you'd probably want to use this for other things. For example, any kind of human character or animal or anything like that is probably a good candidate for a model that has an internal bone structure. But let's take a look at this model in Lightwave and see how it's set up. And so when you're creating your model with an internal bone structure, you'll want to set it up in a similar manner. Okay, so first of all, we see the model here, and in the layers panel, I see that it has two layers. The first is the body layer, or what I've called the body layer, and you can name that layer whatever you want, but that's the layer that has the geometry in it for the model. So it's kind of a four-pointed star with another point on the top, so it kind of has 5 points to it. And just has one texture on it, so nothing nothing fancy, just a single texture, single UV map. Now there is another layer to this model, and it's called skeleton. Now for purposes of the GX engine or the GX toolkit, when it loads in a model that has an internal bone structure that we're going to animate directly in the program, in other words, we're going to procedurally or programmatically animate these the model by moving the bones around. And in order to get the toolkit to load in this layer of data that containing the bones, it's going to have to be named skeleton. So that's going to be important. So be sure that you have a layer that has your geometry in it, that has the vertices and the polygons, and that's textured and so forth, just like normal. And then you need a secondary layer, and be sure to name it skeleton. Okay, and so you can see the bone structure in this layer. It has 6 different bones. So there's a bone at the bottom, and then that's going to be what we call the root bone. So the root of the skeleton is basically the beginning point or the attachment point of the first bone. So at the very bottom of this bone, at the base of it, would be where the root of this particular skeleton structure is. Okay, so that's the first bone. And then it has connected to it 5 other bones. So there's a point where this root bone comes up, and then we've got 5 other bones that are connected to that bone. Now, when you're creating a skeletal structure, there's really no rules. I mean, you create it the way, however you want, but bones cannot be disconnected from each other. So I couldn't have a bone that's not connected to one of these other bones. So you'll always have your bones connected to each other. Now there will be times when, for whatever reason in the model, you may want to have a bone that's sort of, distant from the other bones, and that's okay. But what you'll have to do is create another bone that in between that connects it to the rest of the bone structure or the skeleton structure. So the bones will always have to be connected, but there are times when you create what I would call placeholder bones, and they're simply to provide connections for other bones that are more distant. So it is okay to have bones that you're planning on moving by themselves, and they're kind of distant from the rest of the skeleton, but you'll have to create placeholder bones that fit the rest of the skeleton to that particular bone, because they always have to be connected. Now I should mention that in Lightwave, bones in Modeler, that is, in Lightwave Modeler, which is the program we're in here, bones are not called bones, they're called skelegons. Now the other half of Lightwave is another program called Layout. And in Layout, the bones are called bones. And basically, what we do is typically the pipeline will be, we'll create a model in Modeler, a 3D model in Lightwave Modeler. We'll create these skelegons internally, and we'll attach the skelegons to the model, and we'll see how to do that in this video. And then later, when you get to the point, if you want to import this model containing the skelegons into Layout, then at some point you have the option to convert the skelegons into bones. And so we'll talk about that next week. For now, we'll spend our time completely in Modeler for in this week, and then next week we'll look at Layout. But anyway, these are called skelegons. However, in this video I may end up calling them bones, but it's really the same thing. Okay, now once you create your bones or your skelegons in the model, there's a couple things you'll need to do to actually get them attached to the geometry of your model. However, one of the other things that you're going to want to do is name these bones or these skelegons. And again, I think I'll just refer to them as bones. But go to the Setup tab in Lightwave, and after you've created your structure of bones, then you can go to under Skelegons on the left hand side, you'll see something called Skelegon Tree. Click that and you'll see a listing of all the skelegons in the model. And on the left side you'll see the name of the skelegon. And so I've already named these, and let's see. Alright, so we've got, and it's when I click on them, they don't light up in the interface, unfortunately. I wish they would. But notice that we've got a skelegon named Base. So that's the one at the very bottom that I mentioned, the root bone. And then we've got bone 1, bone 2, and bone 3, bone 4. Those are the 4 bones that are positioned horizontally. And then this top bone, this vertical bone, is the one that's called top. And if you want to rename the bones, usually after you've created the bones, it gives them some strange names. So what you can do in the Skeleton tree is you can just double click on a bone and it allows you to rename it here. So this is another thing that you're going to want to do if you're planning on manipulating this bone structure directly in your program, which is what we're going to do here. Then you're going to want to give each bone some kind of name that you can remember in your program. So you'll be using these names as strings. So be sure that you name them appropriately, and that makes it a lot easier. On the right side, you'll see what's called a weight map, and we'll discuss that in a minute. But initially, when you create a model, the first thing you're going to want to do is create the geometry and maybe texture your model, which I can see here. The next thing you'll do after your model is created is you'll double click in the layers panel below your first layer, and you'll create a new layer, and again you'll name it skeleton, and then you'll start the process of creating your bones, which I'll give you an example of that later in the video. After your bones are created, you can go to the skeleton tree and name them, and over here on the right where it says weight map, this should be empty. The process that comes after that will be you'll want to attach each of these bones to the geometry of the model, and so we'll use basically a painting technique to do that. And each time we do that, it'll create what's called a weight map. And so the weight map is basically list all the vertices in the model that are attached to a particular bone. And so for that reason, each of these bones will have their own weight map. And so when you're creating the weight maps, I typically like to give them the same name as the bone. So this, for example, this first bone is named base, and the weight map is named base. So those are two different things. There's the bone itself, and then there's the weight map, which is the mapping mechanism that attaches the bone to the vertices of the model. And so I just renamed it base as well. And so that way it's easy to keep track of which weight map goes with which bone by giving them the same name. Let's talk now about the mechanism by which the bones are attached to each other. Now, when you start creating bones in Lightwave, after you create the first bone, the second bone will automatically be attached to the first bone that you've created, which will become the parent. So as you create them, they'll attach to the last one that you created, and sometimes that's okay. But in a situation like this, where I have multiple bones, in this case 5 different bones that are all connected to this bottom bone. So this bottom bone here, which is the base bone, has 5 child bones. So it's the parent of these 5 child bones. So there are going to be times when you're going to want to set up the parent-child relationship of these bones in a certain way. And for that, you can do that using the skeleton tree. It's kind of not apparent just by looking at it that you'd be able to do that. But let's suppose that I wanted to take the top bone and set it as, for example, make it the child of bone number 1. So what you can do is just with your left mouse button, just click on it and then drag it, and you'll see this white line show up. Drag it underneath and put the white line underneath the bone that you want to attach it to, the bone that you want it to be the parent, that bone to be the parent of it. So I'm going to do that, and let me try it again. Okay, it's a little tricky. There it is. Okay. I'm not sure why it's tough to do that. Basically, you have to wait till you see the white line indenting, so it dents a little bit to the right, and then you can release your left mouse button, and it'll go ahead and parent that. Now, notice what happened when I did that though was that top bone shifted over from the middle of the skeleton over all the way over to the end of one of these bones. This is bone 1 that it moved to. And the reason that it had to do that is since bone 1 is now the parent of this top bone, then the base of the top bone, which is the wider end of the bone, you'll notice that each bone has a wide end and a narrow end, but the wider end of the bone is the beginning, the narrow end is the end. So it had to move the beginning of the top bone to the end of bone 1 in order for it to set up that parent-child relationship correctly. Again, bones always have to be attached to each other. Now if I wanted to move it back, I could simply drag top back to base. So now it's the top bone is correctly attached to the end of the base bone. So by dragging these bones around and dropping them underneath, you can set up the structure that you want. Now, so we've talked about the geometry of the model, we've talked about the skeletal structure. Let's talk about the attachment mechanism. So remember, each bone has a weight map. So let's talk about how that's set up. Alright, so basically what you're going to want to do is the following. Okay, so make sure that you have both the geometry of the model and the skeleton shown in the foreground. So in the layers panel, I'm going to click on the F letter. Okay, so now I can see in the foreground both the geometry and the skeleton. Although it's a little tough to see the skeleton since it's inside, but I can still see it. Now, make sure you're in polygon selection mode, and then go to the map panel and click on vertex paint. Okay, so now you see this tool come up, vertex paint. So initially, when you don't have any attachment of your bones to the model, what you'll need to go and do in here is set up the attachment. Okay, so you've got some tools here that allow you to move the model around, which is going to be something you're going to need to do as you're working on this. First of all, click on weights, and then you'll see the list of your bones, all your different bones, and you can click on one of your bones. And initially you won't have this set up, but I've already painted these weights on. But what you see in red here is the influence that this bone has on the model. Or another way to say it, any vertex in the model that's painted red is attached to this bone. And in some cases it'll be very dark red, which means it's 100% attached. And in some cases it may only be very, very light red, which means that it's only attached by some, percentage, maybe 50% or 20% or whatever. So what you can do is if you needed to, for example, change this map, and sometimes you need to do that after you've created it, you take a model into a program that you've written and you see that it doesn't really work correctly, you can go and update this weight map. So what we're seeing visually is the weight map. So it's the set of vertices that are attached in the model that are attached to this bone and the relative influence that each of the vertices that are attached has. So I can click on add, for example, and then go over here and then left mouse click in the view window, and I can drag this around and click on different areas, and I can highlight the model. So I can, now it's set only to 20%, so every time I click on an area in this circle here that's over a vertex, like this one here, it's going to add 20%. So I'd have to click on a particular vertex 5 times in order to add 100% weight. So that's the process, and if we want to subtract, then we can do that as well. So we can subtract. Okay, so we'll have another example in the video of how to do this, but I just wanted to show you how it's set up. Again, when you click through the various bones, you'll see how they are attached to the model. Next, let's look at the code that reads in and draws this particular model. So I'm in demo 12. And you can see there's two models that are being loaded. There's a floor model that has a couple of different, it's got 3 different textures associated with it, floor marble and inverted marble. And then here's our flower model. So let's take a close look at it. So we're reading in the model, the name is flower.lwo. And in addition to reading in the texture coordinates, we also need to read in the weights, because this is a model that has a skeleton, and therefore it's got some weight maps associated with each bone. So you're going to plug in both texture coordinates and weights. So be sure to do that. Next, Lightwave won't, or the toolkit rather, won't automatically attach the skeleton that's being read in. Remember, there's a layer in the model that's called skeleton, and there's another layer that has the actual geometry in it, but it won't attach the skeleton to the geometry unless we tell it to do that in the toolkit. So we're going to say GX3D skeleton attach, and so it'll go and search for a particular layer in the model named skeleton. That's why we needed to name it that, the bones layer skeleton, and then it'll go and attach each one of those bones to the vertices of the model using the weight maps that we created. All right, so be sure you do that. Next, we're going to load the texture for this model. Okay, now we'll get to the part of the program where we redraw this model, this flower. So the code's not terribly long, but we need to look at it. All right, in this case, what we're going to use is, for rendering, we're going to use a reflective material. Okay, so this is another thing new in this demo that I want to show you. And in addition to plugging in what I would call a reflective material or a shiny material, in order to see this, we're going to enable specular highlighting or specular lighting. Now, let's stop a moment and take a look at this material. What's important about a material in Direct3D is if you don't have a texture on your model, then the color that gets rendered that you see on the screen comes from the material color. If you have a texture, then the color comes from the texture. However, you still need to enable a material whenever you're rendering a model. And even if you have a texture on your model, there is one important thing that can be added to the rendering from the material, and that is the reflectivity, or the specularity, I should say. Alright, so notice the difference between the default material and the reflective material. The only difference is this value that we have for specular sharpness. In this case, it's a 15 instead of a 0. So when it's 0, then specularity is disabled. And what specularity is, it's a shininess factor. So think about a surface like metal, chrome or something like that. When you shine a light on it, you not only see the color of it, but depending on the way the light is shining on it, it may have a very bright spot, a shiny spot. All right, so I think reflective is probably not the right word here. It probably should be something like material shiny, because we're not talking about really the reflectivity of it. We're talking about the shininess. And so you can control how shiny an object is going to be using this parameter. And you can go from a very sharp reflection to a very diffuse reflection. So there's some typical values. But I find that usually it's a process of trial and error, where when you're rendering a model and you want it to look a certain way, you have to play around with this value to get it where you want. Now, just plugging in a value other than 0 for the specular sharpness in your material does not give you the shininess. In addition to having this set in the material, you also have to enable specular lighting. And so that way, when the rendering is computing the color values of each pixel in your model, it will take into account that shininess factor or that specular factor. Okay. Also, we've got some other lighting turned on, and that's key, of course. With specular lighting, you're going to need to turn on a dynamic light. So that way, the dynamic light will interact with the model, and then you'll get that shiny component that you see. Next, I've got a variable that's just going to move around one of the bones. So it's called angle, and it looks like it's just going to go back and forth between about 30 and negative 30 degrees. That's just so we see this model moving around. Next, we're going to go through and do some animation. So notice we're not going to animate all the bones, but we're just going to animate a couple of them. So the process to do that is we need to create a pointer to something called a GX3D skeleton bone. So this is going to be one of the bones in the skeleton layer. And we need to get a handle to it. So we're going to call a skeleton get bone, and we're going to pass the name of the bone that we created in Lightwave. And then now that I have a handle to that, I can create a transformation matrix. Now you won't want to use translate or scale, which you could use scale, but most of the time what we want to do is a rotation. So almost always the only thing we do with bones is rotate them. Of course, you could try what would happen if you scaled it. It's possible to use that too. But we're just going to plug in a rotation so this bone will rotate. And then once we've created that rotation matrix, we're going to call skeleton set bone matrix, and we're going to plug in that matrix to that bone. As you can see, now we're going to get a handle to a different bone. In this case, this is the top bone, and we're going to rotate it. Also, notice that for the first bone, we're rotating about the x-axis, and the other bone we're rotating about the z-axis. Now, what does it mean to rotate about the x and z-axis? Well, you have to go back to how the bone was set up in Lightwave. So here in Lightwave, I'm looking down the positive z-axis here in the perspective view. So to rotate the first bone, the base bone, which is the bottom bone, about the x-axis is going to mean, and this is the x-axis is going across here. So it's going to mean that, let me try to grab the bone. Yeah, it's going to mean that the thing is going to rotate like this. It's going to rotate around the x-axis. Okay, so when we say in our program rotate about the x-axis, we're talking about the x-axis as it was defined in Lightwave. Similarly, when we talk about, in this case for the top bone, rotating about the z-axis, again, it's the z-axis as it was defined in Lightwave. Okay, now once you've updated any bones that you want in the model, and it doesn't matter the order, you can update them in any order, you know, one bone, two bones, all the bones. But once you're done, you need to call skeleton update transforms. So it'll multiply together all the various bone matrices so that the animation occurs correctly. So be sure to call this function here after you've animated all your bones. Next, we're going to get ready to draw the object. So as you can see, it's going to be drawn at the origin 0, 0, 0. And in the case of we're drawing in wireframe, which in the program, you can enable wireframe with the T key. Just click the T key when you're running the demo and you'll see the model drawn in wireframe. And then click T again and it'll go back to texture mode. When we're done here, we're going to disable specular lighting. It's not normally something that you want on. By default, it's turned off, so that the next model that you draw, you may not want it on. Now, it turns out in the case of this ground plane or this floor that we're going to draw next, I do have specular highlighting turned on for that, so we could have just left it on. Okay, so let's take a look now at how this program works. Okay, so here you see the flower model, and it's just sitting on a floor model. And so as we go through it, you'll see that very clearly. You can see the top bone moving around, and also the bottom bone is moving too. It's a little bit harder to see, but there, I think you can see it from this angle. And notice how the vertices on the model are stretching. So this is an example of non-rigid body animation. This is also what we call procedural animation, or procedural skeletal animation, because we're animating this procedurally, we're animating it directly in the code. Now, another way to animate a skeletal model in your program besides procedurally is to record the animations, and we can do that in Lightwave's layout module. We can go in and we can create the animations that we want, again by rotating the bones, and then we can save that out as a file, and then we can just basically play it back. Now, there's advantages and disadvantages if you're just writing a program where you're playing back animations. An advantage is using a program like Layout. It's going to be nice because we'll have lots of tools in order to use to create the animation, so we can create the exact animation that we want by moving the skeleton around, and then save it out as a file. Obviously, we save out a lot of data, but playing it back, we're limited to only all the different animations that we recorded. Okay, so as you can see here in this program, since we're using procedural animation, we're not limited to anything that's been recorded. We can go and grab bones, and we can move them around any way we want to. So that gives you a lot of flexibility, but it's also harder from the programming point of view because you have to figure out what it is you want to do here. So there are advantages and disadvantages. But this week we're looking at procedural skeletal animation, and next week we'll take a look at recording the animations and saving them out as data files and then playing them back in our program. A couple of other things I wanted to mention about this particular demo: in addition to the specular lighting, we have the ability to capture a screenshot. This is very useful, particularly when you're creating a portfolio. Anytime that you have a really interesting image on screen from a graphics program that you've created, it's nice to create a screenshot. You might end up losing the source code, or it doesn't work with another operating system, but screenshots you'll have forever, and they can definitely look great on your resume. So I would recommend taking screenshots whenever you think you have something interesting that you want to save. So what we have here in this code is, when we're looking for key presses, if we get the F1 key being pressed, then we're going to set a Boolean here called take screenshot to true. And if you search for that at the end of the render, so after we end up drawing the screen, and we call in render, then if take screenshot is true, then basically we're going to create a file name here, which is, it's going to add an integer to the end. So when you're running the program, it'll take the first screenshot, it'll save as screenshot 0, and then screenshot 1, and then 2 and 3 and so forth. So that way it doesn't overwrite your screenshot. However, when you run the program a second time, you'll start overwriting your screenshots. So if you get something you really like, you might want to save those out to a different directory. But you can see here it's going to write out a BMP file. And one thing I'll say about this code here is it has to lock the frame buffer, and so that's going to cause, in some cases, well, in all cases, it's going to cause the graphics card to stall. So this graphics card is generally trying to render as fast as you can, but when you lock the frame buffer, that's going to tell the graphics card to stop what it's doing, so that way you can get the data out of the frame buffer, capture the screenshot. And so sometimes when you press the F1 key, you may notice a slight delay, and sometimes it may be longer than others, but that's just an artifact of the way this works. We don't normally, when we're when we're rendering a real-time 3D application, we don't normally lock the frame buffer for any reason, but this would be a reason to do it. And you'll see the files that are saved out are going to be in a directory called screenshots here, which I've already saved a couple of files. The other thing I wanted to show you about this program is that it enables context switching. So what that means is you can run your program and it does take up the entire screen, but if you wanted to switch over, switch back to the Windows desktop in order to do something else without quitting out of your program, that's possible. And typically we do that by clicking on Alt-Tab, so the Alt and the Tab key at the same time, and that'll switch back to your desktop. And but now if you try to switch back to your program, and you'll see your program in the bottom taskbar, there'll be an icon, and you'll just click on that icon to relaunch your or reopen your program. Your program shouldn't be stopped. It should come back up and be right back where you left off. Now that doesn't happen automatically. You actually have to write code enabled to handle the context switch. And so we got that set up in this application. Let's see how it works. And the user interface code. There we go. So we're getting events, which we're looking at the key presses, but also we're going to check for an event called window inactive. So this is an event that's going to be sent to your application from the operating system when your application goes off the screen. And so what we'll do there is run a macro, and there's no reason why this restore program code is in a macro. It's just a little bit more convenient, but it certainly could be just typed right directly in here. And then when we come back, we're going to zero the mouse movement counters because we are using the mouse in this program to control part of the camera movement. But let's see what happens in restore program. Basically in restore program, this macro or this code simply needs to wait until our program is back on the screen. It's back in the foreground. So what it does is it goes into an infinite loop, and every time in the loop it's going to look for an event, and if that's the active event, that means, again, it's a message sent from the operating system. That means that our program is back on the screen. And if that's the case, we'll break out of the for loop, and then we have a few little things here we need to do in order to restore DirectX to its previous state and so forth. Now, another thing that can happen when our program is off screen is the user could right click on it and hit close, or from the task manager they could close our application. So there are a couple of things we need to handle there. So another event that we'll look for is this one called window close. Again, it's another event or message that we'll receive from the operating system if our program is being closed externally. And if that's the case, then we'll set this variable quit to true, which will exit out of our application. Okay, so we've talked about a lot of new things. Let's run through the process quickly for creating an object in Modeler that has a internal bone structure. All right, so I'm going to start creating, let's say, a box. And in the numeric panel, I'm going to give it some segments. Okay, we'll give that a name of box. So that'll be the name of our layer that has our geometry in it. Now, at this point, I'd probably also want to go and create a texture map, a UV map, and then add a texture to it. But I'm going to skip that part for right now. But that's something you'd want to do. Next, under the box layer, I'm going to double click and create a new layer called Skeleton. Okay, now with the box in the background, because I really need that in the background so I can see where these skeleton bones are going to be. So I kind of need that as a reference. So now I'm going to go to the Setup tab and click on Create Skeleton, and I'm going to click inside with my left mouse button and then drag. And as I drag around, I can create the ending position for this bone. The starting position was where I clicked on. Okay, so you can see how it's set up there. It might be a little hard to see. Now, if I wanted to create another bone after this, this one is already highlighted, so all I need to do is click in their interface somewhere with my left mouse button, and it'll automatically create another one that's attached to the first one. So you can see that here. So I'll create a second one, and then we'll leave that where it is. Whoops, I accidentally deleted it. I hit the deselect region, so let's do that again. Okay, once you have it the way you want, you can hit the space bar, and now it's there. Okay, now if you want to create another bone, and let's say, remember I can always use Skeleton tree to change the parent-child relationship, but it's easier to try to do it when you're setting it up as much as possible. So let's say I wanted to create a third bone that's somewhat similar to the second one, except it's pointing in the other direction. So in polygon selection mode, I'm going to select the first bone. Then I'm going to click on Create Skeleton, and so now when I create another bone, it's going to create it connected to the one that I had highlighted. Okay, so again, I'll hit the space bar. Alright, so as you can see, I have a structure here, and the way these bones are situated, you can move them around if you want. So for example, I could, before I start attaching them to the model, I could move them around. Say maybe I want to rotate them like this. You might want to stretch one of these out, make it a little longer, and maybe the other one too. So you can definitely make some adjustments. Okay, now I'm going to go to Skeleton tree and make sure these have a name. So notice they have a default name and no weight map, but I'm going to call the first one, which I can see is the parent of the other two, we'll call that the root. And then we'll call this one bone 1 and bone 2. Okay, now let's create the weight maps. Alright, so I'm going to make sure that the geometry and the skeleton are both in the foreground by clicking the F in the layers panel. And I want to make sure in polygon selection mode, I'm going to go to Setup or Map and click on Vertex Paint. And then click on the Weight tab. And now for each one of the bones, I'll paint the influence. I'm going to use add, and I'm going to use a value of about 60%. Well, let's say 50%. Okay. Now, you'll want to paint the influence on the model, and this is probably not the best model, but you'll want to paint the influence of this bone in the model relative probably to where it's at. So in other words, wherever this bone is closest to, whatever vertices of the model that this bone is close to, then you want to give those vertices some influence from this bone. So I'm probably putting more on than I need, but we can remember you can always subtract too. So here I got some on the outside that I didn't want, so I'm going to remove those. And I'm going to set the remove to 100%. So that way I can remove them quickly. Okay, so that's kind of the idea. You want vertices near the bone to be influenced by that bone. When that bone moves, those vertices will move. Then I'll click on the other bones. This one's on the left side, so I'll give some influence of that bone to the left side of the model. And remember, it doesn't. The influence at each vertex doesn't have to be 100%, but it can be. So vertices that are very close to the bone, I'd want them weighted 100%. But vertices like I have here that are kind of pink, they're a little bit further away from the bone, and maybe it would be like this, then those would not have as much influence. They wouldn't be as influenced by that bone. Okay, so that's not perfect, but you get the idea. And now for the other one. And it would be a good idea if for every vertex in the model, it's affected by at least one bone. Another thing I want to mention is this is a limitation in both in the Direct 3D, which is the underlying 3D API that we're using, and also the GX Toolkit. Any particular bone or any particular vertex in the model, rather, can only be attached to at most 4 bones. So again, that's a limitation in the underlying API that we're using. So when you're going around painting, clicking on each bone and painting the influence of that bone onto the model, you want to try to make sure as much as you can that for any particular vertex in the model, it's only affected by at most 4 bones. Now, if you have more than that, if you have more bones than that, it'll actually load, but the results can be unpredictable, because basically when it's reading in these weight maps in your program, it'll take the first 4 bones and it'll say, oh, well, these are the 4 bones that affect this vertex, and it'll ignore any others. It's probably not going to be what you want. So it's much easier to try to make sure that any particular vertex is only affected by at most 4 bones. Now, how will I know if there's a problem and a vertex is affected by more than 4 bones? When your program runs, it'll output some information in the debug file, which I don't see any of that here, but you'll see some information in the debug file. It'll say essentially, a certain layer in the model has more than 4 bones, attached to some of the vertices. So that'll kind of be your clue then that there's a problem, and you got to go back into Lightwave into Vertex Paint, click on all the bones and make sure there's not some stray bone that's affecting vertices it shouldn't. For example, like I wouldn't want to have this bone that's affecting the vertices on the left side to suddenly have some influence over here on vertices on the right side. See, so that wouldn't be appropriate. So that would be a matter of just going in and erasing those. You can spend a lot of time in Vertex Paint in setting up the influence of the bones on the model, and really the weight mapping is more of an art than a science, and it's getting the weight maps just right that's going to allow your model to look good. Now when you run a model and in your program and you animate it and you see that there's a problem, then as far as the stretching of the vertices, maybe some vertices are stretching too much or not enough, it's probably almost always a weight map issue. Like in this example here, you can see that for the most part this weight map is pretty even. However, there is some vertices. There's a vertex here, another one here, that have some heavy weights on them attached to this bone, and that's not really symmetrical across the face of this model. Also, there's a vertex right here that has not as much influence as the vertices surrounding it, and that doesn't seem appropriate unless there was a particular reason. So that would be a situation where I'd just come back in and tighten up on this and get it to where it looks the way it's supposed to. So again, when you're running your program and you see issues with the stretching of the model, it looks like it's something unnatural or it's something it's not the way you wanted, just come back into your Vertex maps, make some changes here in Vertex Paint, and almost always fixes the problem. But again, as I mentioned, it's really more of an art than a science. After I'm done, I'll just quit out of Vertex Paint. It'll ask me if I want to save all those changes, and I'm going to say yes. And now in the Vertex Maps panel, I can click on Weight Map, and I see there is a weight map now for bone 1, bone 2, and the root bone. You also see this thing called Subpatch, which you can ignore. And if I go to the Setup tab and click on Skeleton Tree, I see now that each one of the bones has a corresponding weight map. And so at that point, I would save the model.